Okay, we are in section 6.6 where we're going to solve radical equations. The steps in order to solve radical equations is this. Step 1, I want you to isolate the radical on one side of the equal sign if you can. Second step, you raise both sides to the power to remove that radical from the equation itself. And then last step is you solve for the variable. So if we look at our examples here, I want to solve for the radical of the equation by raising it to the appropriate power and then checking for the solutions. So first off, in example A, I have the square root of 4x minus 5 equaling 2. Here, my square root is isolated, so that's step 1. Second step is to raise it to the appropriate power. So since it's the square root is like raising it to the 1/2 power, I'm going to square it so then I can get it to the first power. So I'm going to square both sides. If I square the left-hand side, all I'm going to get is just 4x minus 5. You get rid of that square. Equals, now I just take 2 squared, which gives me 4. Now from here, I just solve for x. So I'm going to add 5 to both sides, so it's 4x equals 9. And then dividing both sides by 4, I get x equaling 9 over 4. Okay? In example B, I don't have my square root isolated yet. I have a plus 5 on the left-hand side of my equal sign. So I'm going to subtract 5 to both sides, which leaves me with the square root of negative 3x plus 10 equals 7. Now, since it's isolated, now I can square it. So on the left-hand side, I have negative 3x plus 10 equals 49. Now I can solve for x. So I'm going to subtract 10 to both sides, so that's negative 3x equals 39. Dividing both sides by a negative 3 gives me x equals a negative 13. For C, again, my cube root this time is not isolated, so now I must add both sides by 9. So now I got the cube root of 5x minus 8 equaling 2. So since I got the cube root of 5x minus 8, and I want to get rid of that, so now I have to cube both sides. So my left-hand side was just left with 5x minus 8, and 2 cubed will give me 8. Now I can solve for x by adding 8 to both sides. So I'm going to go 5x equaling 16, dividing both sides by 5, gives me x equals 16 over 5. Okay. These next examples deal with rational exponents. Still the same rules apply for rational exponents as it is for radical equations. I still want to get my rational exponent isolated on one side of the equal sign and be able to solve for x. So I'm going to add 1 to both sides, which gives me x minus 3 to the 2/3 power equaling 9. So what I want to do is I want to get that exponent to be 1. So using the power of powers rule, I'm going to multiply it by its reciprocal to the, or I'm going to raise it, I'm going to raise it to the reciprocal of that radical. So I'm going to raise to the left side to the 3/2 power, and I'm going to do it to the right-hand side. So because using the power rule, you multiply the exponents. So 2/3 multiplied by 3/3 gives me 1. So I'm just left with x minus 3 on the left-hand side equaling 9 to the 3 halves power, and 9 to the 3 halves power is 27. Now I can solve for x, so I'm going to add 3 to both sides, so x will equal 30. In b, I must isolate my radical exponent, so I'm going to subtract 8 to both sides, so I'm going to say 2 times 3x minus 8 to the 3/4 power equals 162. Dividing both sides by 2, I'm going to have 3x minus 8 to the 3/4 power equaling 81. Now from here, I'm going to raise it to its reciprocal. So I'm going to raise it to the 4/3 power, and I'm going to raise 81 to the 4/3 power. And this gives me, on the left-hand side, just 3x minus 8 equals, and I'm going to say it's roughly 350.5. It's a longer decimal, but I'm just going to approximate for this situation. I'm going to add 8 to both sides, so it gives me 358.5. And dividing both sides by 3, x will give me roughly 119.5. Here, I have equations with square roots with a variable both in the square root and outside of the square root. So it is very important here to check for your solutions. Okay, so here I got the square root isolated, so I'm just going to square both sides. Now, x minus 10 quantity squared is not x squared plus 100. You have to remember that x minus 10 quantity squared is the same thing as x minus 10 times x minus 10. So you must use FOIL in order to solve this equation. And if you were to FOIL out x minus 10 quantity squared, you would get x squared minus 20x plus 100 equaling, this is just 9x. Okay, so now what I want to do is I want to set my equation equal to 0. So I'm going to subtract 9x to both sides. So I got x squared. I got like terms with negative 20 and minus 9x. So I'm going to go minus 29x plus 100 equals 0. From here, you can do one of two things. You can reverse FOIL, or you could use the quadratic equation. I've noticed that I can use reverse FOIL here. So I'm going to say x and x. My plus 100 tells me that my signs are going to be the same. My b tells me that they're both going to be negative. And the two values that will help me solve this problem are 25 and 4. So using the zero product property, I can say x equals 25 and x equals 4. Now, if I look, going back to my original equation, so what I'm going to do is I'm going to erase this a little bit so I can get back to my original equation. So my original equation is x minus 10 equaling the square root of 9x. So if I use 25 in my equation, 25 minus 10 is 15. Then keep that in mind. If I go to the right-hand side of my equal sign, 9 times 25 gives me a value of 225. So the square root of 225 is 15. So x equaling 25 checks out. So now if I go to 4, if I say 4 minus 10, that gives me a negative 6. And on the right-hand side, 9 times 4 gives me 36. The square root of 36 is 6. And negative 6 cannot equal a positive 6. So I cannot use the solution for 4 for this particular problem. So the only answer that works is x equals 25. X equals 4 turns out to be an extraneous solution. Okay, let's go to B. B, my fourth root is already isolated, so I'm going to take the fourth power to both sides, which leaves me with 3 minus 8x squared equaling 16x to the fourth. Now what I want to do is I want to get both, I want to have my largest degree, which is x to the fourth, as a positive coefficient. So I'm going to move everything to the right-hand side of my equal sign. So I'm going to have 0 equals 16x to the fourth plus 8x squared minus 3. Now if I reverse FOIL this, I notice that I could do 4x squared, 4x squared, and I could do a plus 3, and I could go minus 3. If I use the zero product property here, if I use the zero product property on 4x squared plus 3, now imagine that I go 4x squared plus 3 equaling 0. I go 4x squared equals negative 3. Dividing both sides by 4, now I got x squared equaling negative 3/4. So if I try to take the square root of this, I am square rooting a negative number, which means is I'm going to get an imaginary number, so this solution cannot happen. If I go to the other parenthesis, I can go 4x squared minus 1 equaling 0, 4x squared equals 1. Then I can go divided by 4, x squared equals 1/4. Taking the square root of both sides, I can say x equals plus or minus 1/2. So let's try these values here. So if I took 1/2, well both, if I say positive 1/2, positive 1/2 squared, going back to the original equation, positive 1/2 will give me, squared will give me 1/4. 1/4 times 8 is going to give me 2, so 3 minus 2 gives me 1. The fourth root of 1 is 1. And if I go to the other side of the equal sign, positive 1/2 multiplied by 2 gives me 2. And if I use the negative, it's going to be the same thing on the left-hand side. I'm going to get a positive 1, but on the right-hand side, it's going to give me a negative 1. So I can't use the positive 1/2. The only answer that works, or I can't use the negative 1/2, I'm sorry. The only solution that works is a positive 1/2. The last two examples deal with equations that have two radicals. So here, you really can't isolate one or the other. So you can just, what I'm going to do is I'm just going to square both sides. And by doing that, I'm just removing the square root from both sides of my equal sign. So it leaves me with x minus 20 equals 3x plus 46. Now I can get x by itself, so I can go, I'm going to subtract by 3, which gives me 6x. Then I'm going to add 20, which will give me 66. And it leaves me with x equaling 11 if I divide both sides by 6. My last example is I have the square root of 3x minus 8 plus 1 equaling the square root of x plus 5. So again, I really can't isolate anything, so I'm just going to square both sides. Now here, you have to keep in mind that on the left-hand side, it's the square root of 3x minus 8 plus 1 multiplied by the square root of 3x minus 8 plus 1. So if I were to FOIL this out, I get 3x minus 8 plus 2 times the square root of 3x minus 8 plus 1 equaling just x plus 5. So from here, I got like terms here, and I got like terms here. So I'm just going to combine those. So I got 3x plus 2 times the square root of 3x minus 8 minus 7 equaling x plus 5. Now, what I want to do is I want to isolate that square root. So I'm going to add 7 and subtract 3x to both sides, which leaves me with 2 times the square root of 3x minus 8 equaling negative 2x plus 12. Yeah. Now I can divide both sides by 2. So which leaves me with square root of 3x minus 8 equaling negative x plus 6. Now from here, I can square both sides, which leaves me with 3x minus 8 here equaling, if I FOIL this out, I get x squared minus 12x plus 36. So now I can set everything, I can set my left side equal to 0. So now I got 0 equals x squared minus 15x plus 44. So I'm going to reverse FOIL here. I got x and x plus 44 means they're both going to be the same. My minus here means they're both going to be negative. So this is going to be 11 and this is going to be 4. Using the zero product property, x will be 11 and x will be 4. So if I go back to my original problem, I'm going to erase these parentheses and squares. If I use 11, 11 times 3 is 33, minus 8 is 25. The square root of 25 is 5, plus 1 is 6. On the other side, I have 11 plus 15 will give me 16. Square root of 16 will give me 4. So those two, so when x equals 11, it will not work in my particular equation. So now if I use 4, 4 times 3 is 12, minus 8 gives me 4. Square root of 4 is 2. 2 plus 1 is 3. If I use x is 4 on the right-hand side, 4 plus 5 is 9, square root of 3 is, or square root of 9 is 3. So 3 equals 3, checks out. So the solution that I need is x equals 4. And that is solving radical equations. Hope this helps. Until next time.